We have a diagonal segment here on the graph. If I want to determine the length of this segment, I can't simply count the units or count the boxes of the grid. I'm able to do that for horizontal or vertical lines, line segments, but not for a diagonal one. So instead, I'm going to turn this segment into the hypotenuse of a right triangle. So imagine that segment RS is a hypotenuse, and we're going to draw in the entire vertical distance between those endpoints and the horizontal distance between those endpoints. Now, do you see a right triangle? So this we know is a right angle because we have a horizontal segment and a vertical segment intersecting, so they create a 90-degree angle there. So now this is a right triangle. This is helpful because for any right triangle, we can apply the Pythagorean theorem. So if I know 2 of the side lengths of this triangle, I can determine what the third length would be. As a reminder, Pythagorean theorem is a squared plus b squared equals c squared, where c has to represent the hypotenuse. So RS is C. The 2 blue segments that I drew are A and B, and we can figure out the lengths of those segments by just counting. So I'm going to name this point T just so it's easier for me to refer to. So segment RT, that horizontal segment, I'm going to count the number of units to know the length of that segment. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And the vertical segment, TS, is 1, 2, 3, 4, 5 units. So I have a right triangle. I know the lengths of both legs, so I can determine the length of the hypotenuse, which is the segment I wanted to find the length of, RS. So let's plug everything in. So I'm going to replace A and B with 9 and 5. Those are the lengths of the legs. So 9 squared plus 5 squared equals c squared. 9 squared is 81. 5 squared is 25. That's still equal to c squared. So when I find that sum, 81 plus 25, I get 106. So 106 equals c squared. To figure out what just c is, I want c to the first. I need to do the inverse of this square. So the inverse would be taking the square root. I have to do that to both sides. Sometimes you'll be asked for the length of a segment and told to keep it as a radical. So in that case, the answer would just be radical 106 or square root of 106. If you're asked to find the answer to the nearest tenth or to the nearest hundredth, you would actually take that square root in your calculator. And for this one, when I do that, it's 10.29563, and it goes on. So if I had asked you to round to the nearest tenth, for example, it would round to 10.3. Okay, so 2 different ways that I may ask for your answer, expressed in radical form like this, so left as a radical, or rounded to a specific place.